So what I wanted to show here is I've been doing some research on rodin coils, and I decided to make one. And what I found is the L2 on these sec circuits is very sensitive. I got this one here, which I purposely made kind of not very well, and it doesn't work. If I put this in there, it's very sharp tuning, and if it does come on, it's not good results at all. This one works. I wrapped it. It's kind of like a bifilar. This one works pretty well, but it's got sharp tuning and it's limited to its frequency. And by this frequency, it can stimulate other coils into their oscillation. So what I found is when I use this caduceus coil as an L2, it works pretty, it oscillates at every frequency and gives really good results. This rodin coil also works, so it is creating a magnetic field and a collapse of it. So it works in a sec circuit, which I think can offer a lot more ideas and problems at the same time. But we charged the battery again. I mostly just do that to see how well it works and if I can put energy into it. So this particular configuration just has the caduceus coil connected, and the coil that is going to these coils to stimulate it is being stimulated by the caduceus coil. This one wire is that coil, not connected to the circuit at all, so it's just being stimulated by the caduceus coil. What I thought was cool, and I know One Stop Energies, a guy, Daniel Nunez, has been posting some things on YouTube about how these rodin coils work, and I wound this one here and put an LED across it, and found out that it lights up, and that's pretty neat. So there's a little vortex going around that's pushing current through as this thing oscillates, and you know, it doesn't do it around any of these. So these regular inductors do not vortex anything. They pretty much kind of suck. But I mean, when this one is near them, this can cohere energy and show that there's some energy around here, but it's all longitudinal, and this is giving some different effects. So I thought that was really neat, that we can light an LED up from that and from the bottom. Oh, I just unconnected it. Also, another cool thing that I've been noticing is my transistor is not connected to my resistor. So usually the circuit can only be on when the resistor is on, and this circuit will turn on without that resistor stimulation. So it's almost as if this little circuit here, this oscillator part of the sec circuit, is already oscillating, but so far it's only really done that with this vortex coil. So that's interesting. Also, the spectrum on it is really clean. There's with normal inductors, you'll see like some big humps like all across here. It'll make all these different frequencies, and sometimes it'll make harmonics all the way out to here and stuff. It's really just a big mess. But this is going, it's resonating very nicely. I usually try and get this one right here on 4.4. At 4.4 megahertz is the base frequency. It makes a third harmonic around 13.4 megahertz, and that, I guess, is constructively interfering with another frequency that's already out there. So it resonates well. It resonates at any frequency you give it, so it can stimulate other coils much better because it's not limited to its own resonant frequency. So I would encourage other people to replicate these little rodin coils, and I actually made this one out of one of these. It is pretty easy. You put 12 points on it, 30 degrees apart each, and I just took a saw and cut lines in it and wrapped it in the star configuration. It didn't take me too long, and I've made an inductor that is not accepted at any universities for research. So this is it's pretty easy and it's pretty astounding. Thanks for watching.